Good afternoon. Welcome to AP Statistics. This is Tuesday, and your homework is due. So I'm Mr. Royes. I will be your video sub for today. You also have a live sub in the room, so please take out your homework that's due today. It's a paper submission, and one person in each group deliver the pile to live sub. I'm going to pause the recording. You can do the same until those assignments get turned in. All right, we're back. The lesson for today is going to begin with an episode of Statistics in the News. So here's an article from the Telegraph. Let's read it together. It says, Fukushima cesium leaks equal 168 Hiroshimas. The purpose of this episode of Statistics in the News is to help you understand what a standard deviation is. Today we're going to learn about standard deviations. So in this article, which is dated August 25th of 2011, which was not too long after the Fukushima nuclear disaster as a result of tsunami produced by an 8.9 earthquake in Japan. The subtitle of the article is Japan's government estimates the amount of radioactive cesium-137 released by the Fukushima nuclear disaster so far is equal to that of 168 Hiroshima bombs. And in this picture here, we see a picture of apparently a scientist measuring radiation levels on children. It's like, this is what it looks like when science is happening. It's like, watch out, kid, we're doing science. Officials in protective gear check for signs of radiation on children who are from the evacuation area near the Fukushima nuclear plant. So, reading the article from the Telegraph, it says, government nuclear experts, however, said the World War II bomb blast and the accidental reactor meltdowns at Fukushima, which has seen ongoing radiation links, but no deaths so far, were beyond comparison. You can't compare Fukushima to Hiroshima, according to this writer, and, well, according to government nuclear experts. The amount of cesium-137 released since the three reactors were crippled by the March 11th quake and tsunami has been estimated at 15,000 terabecquerels. The Tokyo Shimbun reported, quoting a government citation, or a government calculation. Okay, that compares with the 89 terabecquerels released by Little Boy, the uranium bomb the United States dropped on the western Japanese city in the final days of World War II, the report said. So, isn't it interesting how nobody really knows, at least nobody here in the room understands what a terabecquerel is. It's a unit of radiation, and it can be used to measure the amount of cesium-137 released. So here's the problem. Just like the difference between the percent of first-class passengers who survived on the Titanic, which was about 62%, and the overall percentage of people who survived on the Titanic, which was 32%, that deviation, that amount from 32% up to 62%. It's like, how do we really measure that? How big is that? We need a yardstick. The yardstick is a standard deviation. In the same way that the amount of radiation released at Hiroshima, right there toward the end of World War II, that amount of radiation is being used as a yardstick in this attempt to help people wrap their minds around how much radiation was released at the Fukushima nuclear disaster. Nobody can wrap, unless you're like a PhD in physics, nobody really knows what 15,000 terabecquerels are, and that they don't know how to imagine that. However, what people can imagine is the amount of radiation released at Hiroshima. And so what they're saying here is that using Hiroshima as a yardstick for measuring how much radiation was released, Fukushima was equal to 168 Hiroshimas. So notice that in the same way that we're going to be using the standard deviation as a yardstick for measuring and wrapping our minds around the difference between 32% survival and 62% survival. We need a yardstick for measuring that. In the same way, Hiroshima was used as a yardstick to measure the amount of radiation that was released in the Fukushima nuclear disaster. So let's take out, and we do have a handout. I've already given it to you. You already have the handout for standard deviation. It is online for those of you who want to download that. But let's find out mathematically what is a standard deviation. So I'm going to pause the camera while I get this set up. Alrighty, so here's our standard deviation handout. You have that in front of you. Most of you have it on paper. Let's just develop the formula. This formula that we're going to use for standard deviation is for concept development only. You're not going to have to use this formula on the AP test because in AP Stats, the calculators do the heavy lifting for you. You have a TI-84 and it has a standard deviation button on it so that you don't have to actually perform these calculations. Just to help you understand the concept of a standard deviation, we're going to do a few examples of what the calculator will do for you. In this first example, we have data sets 1, 2, and 3. I'm going to adjust that. All right, we're back. So now let's take a look at standard deviation. I'd like you to imagine you have the following data set. Perhaps these are 3 scores you have on 5-point quizzes. You have a 1, a 2, and a 3. That X1 just means the first data value. So these are 3 datums or 3 data. So the N here just simply represents the number of, in this case, quizzes that you took. So N is the number of numbers that we have in this situation. And the symbol beneath the N, X bar, is a symbol that stands for sample mean, which is a statistic. So we have 3 data values, and we're going to calculate the statistic. And the way we're going to do that is we're going to add up the 3 numbers and divide by 3. The average score is 1 plus 2 is 3 plus 3 is 6, and 6 divided by 3 is 2. That makes sense that your mean score is 2. Now, what is the standard deviation of this data set? Well, to figure that out, we need to look at the deviations of each of your quiz scores from the mean. How far do 1, 2, and 3 deviate from X bar? So for K equals 1, for X1, what's the first score deviations? What is the first score's deviation from the mean? So we take the first score minus the mean. The second score is 2. Subtract the mean. Then the third score was a 3. So the deviations from the means are -1, 0, and 1. We're not to the standard deviation yet. We're building up from the mean calculation to the standard deviation calculation. So we have 3 deviations. Notice that deviations can be negative. 1 is 1 below the mean, 2 is 0 below the mean, and 3 is 1 above the mean. In this next column, we're going to take all the deviations in the second column and square them. -1 squared is 1. 0 squared is 0. And 1 squared is 1. I basically took every number from this second column and squared it to get the third column. Now this is a fancy mathematical symbol. It's actually the sigma from the Greek alphabet. That's a capital sigma. And it simply stands for sum. S, or sigma, is transliterated into S. you translate words from one language to another. You transliterate letters. And so sigma transliterates into an English S, which stands for sum. So this symbol basically just means sum all of these up. 1 plus 0 plus 1 is 2. So the sum of the squared deviations is 2. Now, in our next column, we have S squared and S. S squared is a symbol that represents what's called variance. And essentially what we're going to do is take the number that we just calculated in the previous column, which is the sum of the squared deviations, and we're going to divide by n minus 1. Remember, n has a value of 3. So we're going to take the 2 from the previous column and divide it by 3 minus 1. Now, fortunately, the numbers come out pretty nice. 3 minus 1 is 2, and 2 divided by 2 is 1. So in this case, the variance is 1, and the standard deviation is always the square root of the variance. The square root of 1 is 1. So in this case, what we're saying is that the typical deviation of anyone's score from the mean score is 1, which makes sense. Sure enough, 1 is 1 away from the mean, 3 is 1 away from the mean, now 2 is 0 away from the mean, but we say the average deviation is 1. So variance is the almost average. The reason we call it an almost average is if it were a true average, I would take the sum and divide by n. But because we're dividing by n minus 1, it's an almost average. So variance is the almost average of the, and then here we're going to describe what happened here, the sum of the squared deviations. So of the sum of the squared deviations. So standard deviation is always, that word if should be is, standard deviation is the square root of the variance. Now, that was your first example of standard deviation. Getting variance to write it out here. Variance. Okay, so let's do another example. Suppose your scores on these 5-point quizzes were 1, 3, and 5. We still have 3. Write down what you think the average is this time. And so when you add these up and divide by 3, we get 4 plus 5 is 9, divided by 3 is 3. Makes sense, the average score is 3. So would you please fill in columns 2, 3, and 4 on your own? I'm going to pause the camera to let you do that on your own, and I'd like someone in the room to pause the camera also, so that when you're ready to check as a class, you can unpause and see what it came up with. All right, so let's talk through to see what this should have looked like. The second column there should have contained the deviations. So take each of these values and find out what its deviation from the mean is. 1 minus 3 is negative 2, 3 minus 3 is 0, and 5 minus 3 is 2. Now we have to square the deviations to get 404, and the sum of the squared deviations is 8. So now we take the number, this is the number 8 that we just calculated, and divide it by n minus 1. 8 divided by 2 is 4. So the variance is 4, and the standard deviation, the yardstick that we're going to use to measure deviations, is the square root of the variance. Square root of 4 is 2. So this has a standard deviation of 2. No surprise, you can actually see the standard deviation of 2 back in the original set. This standard deviation of 2 means that the typical difference between a particular test score and the mean score is 2. In fact, I would like you to write out that interpretation on the bottom of the sheet of paper here. So here's an interpretation. Now, you will not have to calculate standard deviations on the AP test, but you will be required to interpret standard deviations. So here's the script. The standard deviation of 2 means that the typical difference, typical is actually a reserved word in statistics. It's used to represent the concept of average or mean to the general public. The general public doesn't necessarily know what a mean is, but the general public is familiar with the concept of typical. And your job in interpreting the standard deviation is to make it understandable to the general public. So here's what you're going to be required to say when you're asked to interpret the standard deviation. You would say, the standard deviation of 2 means that the typical difference, think of that as the average difference, and we know it's an almost average difference, but the typical difference between a particular test score and the mean test score, and the mean test score in this case is 3. So a mean test score of 3 is 2 points. Now, notice that the standard deviation has units, and the mean also in a real-world context would have units. These would all be 1 point, 3 points on the quiz, 5 points. So the mean is 3 points. So the mean is 3. What's the standard deviation? The standard deviation tells you how spread out the data is. So you can say, well, the standard deviation is 2 points. And a student, your mom or dad might say, well, what does that mean? What does it mean that the standard deviation is 2 points? Here's what you would say. In fact, I'd like all of us to try to say this out loud together in unison. When I say go, I'd like you to say the standard deviation of 2 means that the typical difference between a particular test score and the mean test score of 3 is 2 points. So here we go, let's try it. Ready, go. The standard deviation of 2 means that the typical difference between a particular test score and the mean test score of 3 is 2 points. Now, how does this connect to Hiroshima, Fukushima? Hiroshima's radiation release was used as a yardstick to measure the amount of radiation at Fukushima. Likewise, this standard deviation of 2 is a yardstick that we use to measure the difference between a particular test score and the mean test score. So we're measuring we're not measuring radiation release with the standard deviation. We are measuring deviations of particular values from the mean value. How far does this number deviate from the mean? Well, I'll tell you what its deviation is. If you got a 1 on the quiz, you were 1 standard deviation below the mean, 1 yardstick. 2 is the measure of the yardstick. Now, I'd like you to try one of these on your own. So, on the next page, please take the data set 1, 2, and 24. So maybe these are scores on a 25-point quiz. You had a 1 out of 25, a 2 out of 25, and a 24 out of 25. Or maybe it's 3 different students taking the same quiz. Would you please fill in all of the columns on your own and calculate the standard deviation? I'm going to pause the camera. You do the same in the classroom. Pause it so that when the class is done, we can go through it together. All right, let's see how you did. The average, well, first of all, the number of test scores is 3, and X bar, the sample mean, is found by adding these up and dividing by n. So 27 divided by 3 is 9. So it looks like the average score, the mean, is 9. So what are the deviations? In this column, I hope that you wrote 1 minus 9, 2 minus 9, and 24 minus 9. So the deviations, which sometimes come out negative, those deviations should have been -8, -7, and 24 minus 9 is 15, so 15. So 24 was 15 above the mean, but how many standard deviations was it above the mean? Well, first we have to square the deviations. So we've got -8 squared is 64, -7 squared is 49, and 15 squared is 225. Now we have to take the sum of the squared deviations, and if we do that, we got 225 plus 100 is 325 plus 13 is 338. Okay, so now I have to take 338, which is the sum of the squared deviations, and divide that by 2, which is 3 minus 1. N is not always going to be 3, but it has been several times in a row. So 338 divided by 2 is, 2 goes into 3 once, with a remainder of 1, 6, with a remainder of 1, 18, 9. So 169, which shows that these numbers are pre-cooked. To find the standard deviation, I have to take the square root of the variance, and the square root of 169 is 13. So I hope that when you calculated the standard deviation, you came up with an answer of 13. In this case, that'd be 13 points if the real world context is quiz score. If these are heights of giraffes, then this would be in points, it would be in feet. The average giraffe height is 9 feet. And the standard deviation is 13 feet. Just, you have to write in terms of the context. So, it's a little bit harder to do that when the cover is on. So what I'd like you to do now is interpret 13 feet in the context of giraffe heights. And your interpretation can be written out on top. It starts with the standard deviation of 13 feet. And I want to make sure we start it out just like we did the previous one. So, looks like we didn't use units right at the beginning. So the standard deviation of 13, and then go ahead and complete the interpretation on your own. So I'm going to pause, you finish it up, and then resume when you're done. Okay, so let's take a look at the interpretation of the standard deviation. So we say the standard deviation of 13 is the typical difference between a particular giraffe height and the mean giraffe height. Of 9 feet is 13 feet. So once again, what do we mean by a standard deviation of 13 feet for giraffe height? We're just saying that that's just the typical difference between a particular giraffe's height and the mean giraffe height is 13 feet. Now, actually, I did leave out the mean giraffe height. Oh no, yeah, there it is, of 9 feet is 13 feet. So, like for example, let's take a look at 24. This giraffe is 24 feet tall. How many standard deviations is 24 away from the mean? Well, it is, it's 15 away from the mean. Its deviation is 15. So we use our yardstick of 13 to measure that deviation. We say that this super tall giraffe is a little more than 1 standard deviation above the mean, because 15 is a little bit more than 13. So how big is that giraffe? Well, it's a little more than 1 standard deviation above the mean. So we are going to conclude the lesson here. What I'd like you to do, as far as homework goes, is to read chapter 4 and have that ready to go for block day. So just take a few notes on that as you read through chapter 4 and be ready to show me a 1-page summary of chapter 4 at the beginning of block day on Thursday. We'll see you then. Have a good night.